Let's look at another example of checking to see if a given function is a solution to a differential equation. So we're looking at example C in this problem. So here we're given the function y is equal to this constant c1 times sine of x minus a second constant c sub 2 times cosine of x. And we want to check to see if that function is the solution to this differential equation, which says if you take the second derivative, that's y double prime, plus the original function y, add those together, the sum is going to be 0, right? So to check, we want to substitute in the second derivative of y in this equation, and of course the original function into the equation, and see if the terms add to 0. So obviously, in order to check, we're going to have to compute the second derivative of the function y. Um, the first derivative is easy to calculate. That's just going to be c sub 1 times cosine of x, right? Okay. And the derivative of, because the derivative of the sine is the cosine, right? And the derivative of the cosine is negative sine, right? So that will cancel with this minus sign in front of the second term. And we'll get that the first derivative is c sub 1 times cosine of x plus c sub 2 times sine of x. All right. Now let's compute the second derivative. So again, the derivative of the cosine is minus the sine, so we're going to get the derivative of this first term is going to be minus c sub 1 times sine of x, and then the derivative of the second term is going to be pretty clearly here, c sub 2 times cosine of x, right? And now this is what we're going to substitute into our differential equation. So let's see, we're going to plug in the second derivative, which is minus c sub 1 times sine of x plus c sub 2 times cosine of x, right? And then substitute in the original function, which is c sub 1 times sine of x, and then minus c sub 2 times cosine of x. And let's see what happens here. Well, it looks like these two terms are going to cancel each other, right? And then these two terms will also cancel each other. So that's nice. The left hand, this expression just simplifies to 0, right? And that's exactly what we wanted, right? The second derivative plus the original function. When you add those two formulas together, you just get 0.